Okay, well, I would like to welcome everybody to the Global Frailty Network's presentation of the Frailty Seminar Series. I'm Sara Espinoza. I'm faculty at University of Texas Health Science Center and the San Antonio VA GRECC. And today it is my honor to introduce our distinguished speaker, Dr. Linda Freed, who is Dean at Columbia University's Mailman School of Public Health, or she's Dean of the School of Public Health, and Director of the Robert N. Butler Columbia Aging Center. Dr. Freed is a mentor of mine and a role model of mine for many, many years, and I'm absolutely delighted that she's speaking with us today. She is a geriatrician and epidemiologist. She has dedicated her career to the science of healthy aging, particularly the science of prevention of frailty, disability, and cardiovascular disease. She has led the scientific discoveries of the definition, diagnosis, presentation, biology, and causes of the geriatric syndrome of frailty. Under her leadership as Dean, Columbia Mailman has developed new dimensions of public health science, from the health impacts of climate change to healthy longevity, and she has become a leader in innovation in public health education. Prior to becoming Dean in 2008, Dr. Freed was the Director of Geriatric Medicine and Gerontology at the Center on Aging and Health at Johns Hopkins Medical Institutions. And that was during that time that I had the pleasure of being a fellow under Dr. Freed. She is the recipient of numerous honors and awards, including the French INSERM International Prize in Medical Research in 2017, President of the Association of American Physicians in 2016. She was the recipient of their Cobra Medal in 2022. Dr. Freed serves on the National Academy of Medicine's Executive Council and recently co-chaired its Global Commission on a Global Roadmap for healthy longevity.
Thank you, and hi everybody. It's really an honor to be here with all of you. Perhaps go to the next one. Thank you. So I'm going to talk about frailty and aging, a topic that if there's any group in the world who knows about it, it's you all. And I hope that I can do it in a way that is supplemental to your thinking. I want to start just by recognizing that we now know a lot about longevity. We've added 30 years to human life expectancy in the West in the last 100 years. And we also know that it's possible to create health across longer lives. And the health outcomes that we're concerned about, both treating and prevention, are many. Perhaps I can briefly just summarize them as the different dimensions of what we call non-communicable or chronic diseases and multimorbidity, and of course, a range of geriatric conditions, including frailty and disability and falls, as well as other things. Today, of course, I'm going to focus on frailty as one of those conditions and try and distinguish it from the other things on this list. Next slide, please, Coco. I'll start just conceptually by saying that geriatricians, of course, have and gerontologists have written and thought about and studied for many years the idea that around in people's 70s to 80s, and the age is variable, there appears to be a diminution of intrinsic physiologic reserves and resilience with aging, which is that horizontal triangle on the right-hand side of the figure, conceptually. And that we have to actually build buffers to compensate, whether it's environmentally or through treatment, to compensate for the decline in physiologic reserves and resilience. This conception underpins a lot of the thinking about what emerges with that decline, which is frailty. Next slide. And I have thought for many years about frailty as perhaps the vulnerability that's the background of our health status on which diseases are superimposed. And that understanding frailty, understanding it's the opportunity for recognizing it, treating it, preventing it, can also lead to being a window into understanding health and resilience, as well as what happens with their loss in terms of the emergence of frailty. Next slide, please. So I think what we can say now is that after the ages of 70 to 80, the risk of the emergence of a new clinical syndrome escalates, one that has a distinctive presentation. Frailty is distinct from any single disease or multiple diseases. It emerges clinically, manifesting through a constellation of signs and symptoms that are associated with the underlying biologic and physiologic alterations. And those who are frail constitute a very high-risk group. High risk in terms of mortality, both in the short and intermediate term, in terms of high risk of disability and loss of independence and falls, in terms of high risk for a poorer recovery from acute illness and surgery, hospitalization, and poorer response to therapy for many conditions. So I'm trying to start with the punchline of part of what I want to say today, and now I'll try and give you some of the details. Next slide. So, of course, for decades and decades, geriatricians have thought that you could recognize frailty when you see it. So what does it look like? Well, one way to think about it, of course, next slide, please, Coco, is just the image of older adults who are frail, which of course we know is not every older adult by any means. Another way to think about what frailty looks like, next slide, please, is through this concept, which is that if you start on the right-hand side of this figure, that we see a condition of sarcopenia or loss of muscle mass with aging that emerges to variable degrees as people get older. Sarcopenia itself, if you go down to the bottom right, contributes to declines in strength and power, and on the right-hand bottom right, declines in exercise tolerance or VO2 max, and also alters resting metabolic rate. We know that those declines in strength and power and declines in exercise tolerance associated with sarcopenia combine themselves to diminish walking speed and to, if you go to the left-hand side on the bottom, and to all of those together predict the development of disability, particularly mobility disability and potentially dependency. We also know that as those occur, that people on the left-hand side cut back on their physical activity. And that even in the presence of very low physical activity in a subset of older adults, we see a mismatch, so that even in the face of low activity, if you go to the top left, you see people with relatively inadequate intake of protein and energy, micronutrient deficiencies, chronic undernutrition, even in the face of very low energy expenditure. And of course, with that chronic undernutrition, the individual can develop a negative nitrogen balance for sure. And if the energy balance becomes too negative in the face of this chronic undernutrition, one sees unintentional weight loss. This vicious cycle, if you will, has been demonstrated to have pairwise associations between every one of these dimensions of a vicious cycle of frailty, but also can be kicked off at any part of this cycle by other conditions, diseases, illness, depression, etc. The other dimension of this vicious cycle, if I can have the next slide, is that it actually is all about energy dysregulation and the individual components of that cycle and in the aggregate, a vicious cycle of dysregulated energetics. Next slide, please. Now, that vicious cycle we have developed a way to represent by identifying people with multiples of those components of the vicious cycle, such that when a critical mass of them are present, you can call a critical mass 3 of 5, an individual could be identified as being frail. Those 5 are weakness, muscle weakness, slowed walking speed, low activity, exhaustion, or a sense of low energy, which is correlated with decreased exercise tolerance and unintentional weight loss. Over the years, we have, next slide, please, operationalized this into a way to characterize people as being frail or not frail, initially in the cardiovascular health study, which is a 4-center prospective observational cohort study of adults, older adults in the US, funded by the National Heart, Lung, and Blood Institute. Next slide, please. We operationalize this as a frailty phenotype to test whether the a priori hypothesis that these characteristics, which in prior studies geriatricians had told us were markers of people who were becoming frail, whether by their co-occurrence, we could identify a subset who was distinguishable and who was at high risk. And we've reported, of course, that by this characteristic, with 3 or more of the 5 frailty criteria present, that the prevalence, as you can see in the second column, increases steadily with increasing age, reaching a threshold probably at the age of 85 and older of a quarter of community dwelling older adults who are frail. And that consistently at every age over 65, there's a higher proportion of women who are frail than men. But the overall frequency in a community dwelling population is about 7% of older adults living in the community who are frail. Now, just finding this prevalence is interesting, but the question is, does it matter? Next slide. We have gone on over the years to demonstrate that it's important to distinguish this characterization of frailty from comorbidity or multimorbidity and from disability. 30 years ago, these were conflated as being identical. And I think the science now shows that they are distinguishable and have different etiologies and different significance and impact, although each of these 3 circles can cause the other, but they are not identical. Next slide. So frailty, we demonstrate, is not the same as disability or multimorbidity. Next slide. Now, does this matter, distinguishing them? Well, we've demonstrated over the years, as have many others, that if 3 or more criteria of the 5 criteria for frailty are present, it identifies a subset of people who, as geriatricians have always said, are at very high risk of adverse outcomes: death, disability, falls, hospitalization, surgery, recovery from burns, recovery from surgery, I should have said, and slowed recovery from illness. This vulnerability is the hallmark of being frail, or its significance in identifying frail older adults. And I'd like to point out that the risks for all of these conditions are significantly elevated if 3 or more criteria present compared to 2. You can see this, next slide, please, in terms of the Kaplan-Meier curves about the survival rates in the cardiovascular health study for adults 65 and older in 4 US communities. Survival rates over, or months to death, over a 36-month period. If you compare in the top line, people who were not frail at baseline, in other words, they had 0 of the 5 criteria for frailty, compare them to, in the middle line, those who at baseline had 1 or 2 criteria, compared to those in the bottom line who had 3 or more criteria. And what you can see is that in the top line, those who were not frail, 97% were still alive after 3 years, compared to only 81% of those who were frail at baseline. Next slide, please. I also want to point out that frailty, we have learned over the years that frailty increases morbidity. Here on this slide, you see risks associated with surgery among people who are frail. And for example, for elective surgery, a 2.5-fold increased risk of postoperative complications for those who are frail at the time of the elective surgery. Longer length of stay, increased risk of discharge to facility rather than home. And that phenotypic frailty improved over the predictive power of existing preoperative risk indices like the ASCA, the LEE, and the EAGLE. Many other studies have been done to show that after surgery, the risks of, for example, postoperative delirium is elevated 2-fold in those who are frail compared to those who are not frail prior to the surgery. That phenotypic frailty prior to kidney transplant increases the length of stay and the risk of early hospital readmission and mortality risk after transplant. So that the presence of frailty modifies the effects of treatments, here surgical treatments, but also we've been demonstrating and others have demonstrated response to medical therapy. Next slide. We've also assessed and demonstrated that this frailty phenotype has the characteristics that are consistent with the clinical definition of a medical syndrome. That definition is, of course, as this group knows, that there is like with angina, a constellation of signs and symptoms that when they co-occur in a constellation, identify an underlying specific pathophysiology. And that it is the constellation that aligns with the presence of that pathophysiology more than any 1 or even 2 symptoms and signs. And we have found this for the 5 characteristics of the frailty phenotype over the years, and shown that actually the aggregate phenotype predicts outcomes like mobility, disability, as I just showed you, significantly better than any 1 or 2 criteria alone. Next slide. So the evidence is consistent with considering this frailty as a clinical syndrome, a syndrome of a constellation of presentations, colloquially shrinking, slowing, and weakness with low activity and low energy. And that when a critical mass of these are present, the whole is really greater than the sum of the parts and predicts poor outcomes. And itself, as a phenotype, appears to be a marker of a vicious cycle of energy dysregulation. Now, the syndrome is chronic and progressive. Next slide, please. And I'll show you that in 2 ways. First, we've demonstrated that early preclinical frailty, where there are just 1 or 2 criteria present, identifies a group who are at high risk, a 2.5-fold elevated risk of progressing to the onset of frailty, 3 or more criteria over 3 years, compared to those who have none of these criteria at baseline. Next slide. And the progression starts with the criteria that are circled in yellow, with diminished strength and muscle mass, diminished slowed walking speed, and cutting back on physical activity. And in 90%, people develop the manifestations of frailty first with these things, and then that's followed by low energy or exhaustion, and unintended weight loss. The exception is patients with selected cancers where they may well begin with the weight loss itself. But the progression, other than 90%, is quite characteristic. So is the consequence. Next slide. So frailty, the presence of 3 or more criteria, and particularly 4 or more, turns out to be a marker of a severe end stage of biologic. Next slide, please. Here you see data from analyzed by Chen-Li Zhu, in which he demonstrated, amplified on the Kaplan-Meier survival curves that I showed you before in the women's health and aging studies. And here you see a survival over 7 to 8 years for people in the blue, for women in the blue who had no frailty criteria, in the red who had 1 frailty criterion at baseline, in the green who had 2, in the I guess tan who had 3, in the gray dotted lines who had 4 criteria at baseline, and in the black who had 5. And you see a stepwise progression in the increased, in the likelihood of surviving over this time period, a stepwise diminution in the likelihood of surviving over this time period as people went from 0 frailty criteria to 5 at baseline. Quite dramatic. Next slide. And you can see this in a converse way, that the risk of death here escalated, particularly when people went from 4 to 5 frailty criteria at baseline. Next slide. That suggests actually that there's a point of no return, that when people have 5 frailty criteria, that the risk of mortality has accelerated hugely. In fact, the mortality rate for a frailty score of 5 is more than 3 times higher than that of a frailty score of 3 or 4. I'd also like to show you next that recovery rates plummet when people have a frailty score of 5. Next slide. And you see that here in the green, the top line, that as people go from 4 to 5 frailty criteria, the likelihood of their being able to recover from their frailty really plummets. Next slide. So with this background, it appears that the frailty phenotype offers a measure for clinical screening that is valuable in terms of looking at progression over time, is inexpensive to collect. It takes about 10 minutes and can be administered by a nurse or a trained non-clinician in the office, that it's suitable for screening and also for targeting. And now I'd like to show you that this phenotype is valuable, not just because it predicts risk, but because it is linked to an underlying pathophysiology that can provide specificity as to the etiology of the development of the frailty phenotype and can be a target for both prevention and treatment. Next slide. So I've been talking really about a phenotype that clinically is maybe above the waterline. I'd like to now delve below the waterline and think about the underlying physiology and biology that is associated with specificity with that phenotype. Next slide. So we certainly have at this point significant evidence that the phenotype of frailty, when it's present, is a marker of underlying dysregulation or deficits in 3 key physiologic, functional, or regulatory systems in the body: musculoskeletal system, metabolism and energy systems of metabolic hormones and deficiencies of micronutrients, protein, and energy, and stress response systems, inflammation and immune function, altered stress response hormones, and the autonomic nervous system. And I'm going to show you a little bit of the evidence on that. Next slide, please. First, I'd like to point out that if you look at 3 different stress response systems and compare the levels of low DHEAS, low IGF-1, and high IL-6 with frailty status, going from non-frail in the green to pre-frail in the yellow to frail in the red, what you see is that the greatest rates of abnormal status of those 3 systems occur in those who are frail, and there's a stepwise association in parallel for each of these systems in terms of the increased risk of dysregulation as you go from non-frail to pre-frail to frail. Next slide. You can see also here that the number of systems that are dysregulated is associated directly with the presence of frailty. So as you go from 0 to 1 to 2 dysregulated systems in this universe of metabolic, muscular, and stress response systems, if you go from 0 to 1 to 2 to 3 to 4 to 5 or more, you go from the odds ratios of frailty being 4.8 to 11 to 26-fold increased risk with this increase in the number of systems dysregulated in older adults. Interestingly, if you, next slide, plotting this progression, what you would expect to see is kind of a linear increase in risk, which would be the dotted line here. But in fact, what you see is a curvilinear or nonlinear increase in the prevalence of physical frailty by the number of dysregulated physiologic systems. This is in women aged 70 to 79 who are participating in the women's health and aging studies. Now, this linear model that was expected does not fit what we saw, which is this nonlinear association, which is a particularly important finding in terms of the underlying biology. Next slide, please. Because this nonlinear relationship is actually associated with the biology of the dysregulation of the complex dynamical system that, for example, creates our ability to have homeostasis. So this nonlinear relationship carries a message with it that the whole is greater than the sum of the parts, and that frailty is associated with the critical mass of systems being dysregulated more than any one system. And that this critical mass not only matters, but there's a suggestion that there's a threshold effect where when that critical mass is present, the frailty, the dysregulation associated with it reaches a critical point. Next slide, please. And in fact, may culminate in a critical loss of homeostatic adaptive capacity. Interestingly, when this critical mass of dysregulated systems emerges, that is when the clinical phenotype that I just talked about actually also emerges in our patients. So the presentation of frailty clinically, this constellation of symptoms and signs, is associated with the emergence of a threshold level of decreased function in key regulatory systems that regulate stress response functions, but also mutually co-regulate each other. Next slide, please. You could think about this in a different way. This is a lovely slide that was given to me by Luigi Ferrucci. If you think about the decline in the function of physiologic systems that we have come to understand are associated with aging, and here you see conceptually that decline portrayed over time. Next slide, please. What we are seeing is that when the aggregate number of physiologic systems decline, what emerges in association with that is the phenotype of frailty, associated with a critical threshold level of many stress response systems dysregulated. Next slide, please. So the clinical presentation appears to emerge past the threshold of severity of physiologic decrements. And what's underlying this are the conceptualized components of our homeostatic regulatory systems, which work in a dynamical complex system, where we see loss of physiologic networking and decreased capacity for mutual regulation, diminished redundancy of systems so that if one isn't working, another one would compensate. And then characteristic of complex dynamical systems is that in a steady state, you may not see any problems in terms of ability to respond to stressors, but when the system is stressed, these compromised dynamics should be revealed. Underlying all of this, and a big question, is whether the energy dysregulation indicated by the phenotype is also echoed in the underlying biology and physiology and may drive some of the dysregulation across physiologic systems. And whether ultimately what we're seeing here is a loss of homeostatic robustness and resilience that leads to frailty and is the converse of the resilience of health. What we have seen, and I've shown you before, is that when the clinical presentation emerges in association with this compromise of multiple physiologic systems, that the vulnerability to adverse outcomes also emerges. Next slide, please. So I've told you that clinically, people who are phenotypically frail are also more vulnerable to stressors and at high risk of adverse outcomes. We conducted in the Women's Health and Aging Study 2 a study of initially of women 70 to 79 who were among the least disabled older women in the community, or the highest functioning older women in the community. We sought to understand if there was a difference in how these older women who were non-frail, pre-frail, or frail at baseline responded to stressors. And we studied this in this cohort when these women, after 15 years of follow-up, were 85 to 94 years of age. And we also, in some of the studies, although I don't have time to tell you about them today, conducted other studies of stressors in older male and female volunteers who were 70 and older. Our findings across a whole range of experimental trials of clinical stressors to look at the difference in response by frailty status, the findings were consistent in many physiologic systems. And here I'll show you just several. Next slide, please. So in these women who were 85 to 94 years of age, who were frail, pre-frail, or non-frail at the time of this study, we administered a standard clinical oral glucose tolerance test of 75 grams of glucose after an overnight fast. And what you see here is the mean glucose level and the mean insulin level on the left and the right by frailty status, where those who were blue were non-frail, those who were orange or tan were pre-frail, 1 or 2 frailty criteria, and those who were purple were frail. And what you see is that at the 0 point, which is fasting, fasting in the morning and after an overnight fast before they got the glucose, their mean glucose levels, fasting glucose levels were pretty much identical. But after the administration of the oral glucose, what you see is that those who were frail in the purple had a much more extreme glucose response and insulin response compared to those who were pre-frail or non-frail, and much delayed return to normal. In fact, none of them had returned to normal by 3 hours after the oral glucose tolerance test, but the return to normal of those who were frail was quite delayed compared to those who were non-frail, pre-frail. Next slide. So that gives you some insights both into the difference in stress response by frailty status and consistent, before we look at this slide, with the theory that in complex dynamical systems that are dysregulated, it's only when people are under stress, such as an oral glucose tolerance test, that you can really discriminate those who are frail from those who are pre-frail and non-frail. Talking about glucose and insulin, of course, is also talking about our energy metabolism and utilization systems. And so I'd like to consider also experiments that we did in regard to other dimensions of energy. My patients and study participants have always told me that the thing they thought was the biggest challenge in aging was the decreased energy available to them to do the things they're planning to do and actually undertake in a day. That they hit a wall of, while they're doing something, of suddenly not having the energy to continue. And to look at that, of course, we did a series of experiments. I'll show you one here. Next slide, please. Which was to look at energy repletion in the muscle cells of these 85 to 94-year-old women in response to a 30-second isometric exercise. So this was done in a magnetic resonance spectroscopy study in which these older women were lying in the MRS, and we were testing their dominant leg, looking at their calf muscles during and after they pressed down with as much force as possible with their feet on a force plate, and for 30 seconds. And what you can see here is the time to phosphocreatine recovery after they expended that energy, which is, of course, their maximal effort, but relatively mild exercise. And what you can see here is that the time to phosphocreatine recovery, meaning the time to replenish the ATP in these muscle cells after this energy expenditure, was much delayed in the frail group in purple compared to the non-frail and the pre-frail group. While the difference appears to be clinically significant, it's not statistically significant because the 30 women who underwent this pilot test it was probably not a large enough sample size to show statistical significance. But the difference is quite suggestive that there's a diminution in energy replenishment in the cells and a delay in that in those who are frail compared to those who are not frail. Next slide, please. So these and a number of other experimental trials which we conducted and have reported on have demonstrated parallel findings across multiple physiologic systems. That when people are frail, older adults are frail, that the physiologic dysregulation in a response to a stressor is much more extreme in the frail group than in the non-frail, although they may not be distinguishable before the stressor. And that in the frail group, what we see compared to the non-frail and pre-frail is delayed, exaggerated, and prolonged responses and delayed recovery to baseline, or relative non-response compared to those who are non-frail or pre-frail, and consistently increased variance in responses, less tight regulation, if you will, across systems for metabolic and energy, stress response and adaptive immunity, and the musculoskeletal system. So in summary, next slide, please. What I have been seeking to describe to you is a picture of the different levels of a clinical syndrome. At the top, a phenotype of a critical mass of 3 or more of 5 criteria that are interlinked causally with each other. A vicious cycle, if you will, of a phenotype that also is indicative of energy dysregulation. And that the emergence of that phenotype is associated with perhaps 3 different levels of physiologic and biologic dysfunction. In the center, the dysregulation of 3 core systems that co-regulate each other: musculoskeletal system, stress response systems, and the metabolic system. Aggregate dysregulation in those yellow circles, when it reaches a certain level of severity, then creates what we might call a physiotype, a physical frailty that underpins the physiologic vulnerability to adverse outcomes that is characteristic of those who manifest the frailty phenotype. And likely underpinning all of these alterations are some of the hallmarks of aging, with early data consistent with mitochondrial dysfunction at the bottom, intercellular communication, and cellular senescence as drivers of this dysregulation and dysfunction at every level of the organism above those 3 ovals. Now, this clinical syndrome, which is really everything on this page, clinical presentation that marks a pathophysiologic a presence, is underpinned by the dysregulation of the nonlinear complex dynamical system, which really is the driver of the development of the phenotype. Next slide, please. So just to summarize what I've told you in terms of the biology of complex dynamical systems and the evidence in the Frailty Syndrome, I talked about the nonlinearity of the association of dysregulated systems with the emergence of the frailty phenotype, and the whole is greater than the sum of the parts. That there's evidence for, with increased dysregulation of multiple systems, loss of physiological networking and mutual regulation, loss of redundancy. And all of this is on a platform of dysregulation of multiple subsystems within those 3 major systems of muscle, metabolic, and stress response systems. And that the decreased complexity of this dynamical system underpins the ability to respond to stressors and also marks the loss of reserves. And all of this results in what scientists would call an emergent property. In other words, the threshold level at which frailty emerges and at which you see a transition to function, physiologic function at a lower state than previously. And our evidence of increased risk as people go from 3 to 4 to 5 criteria of frailty indicates that this transition, that there are transition nodes or thresholds across the levels of frailty severity with diminishing physiologic function and function at a lower state, particularly when people go to 4 frailty criteria and 5. Next slide, please. So there's substantial evidence at this point that we're talking about a clinical syndrome that can be diagnosed, that when the diagnosis is made, marks an individual who has had serious losses of underlying physiologic reserve that have reached an aggregate threshold with a result of serious vulnerability to stressors. And the diagnosis identifies someone with recognizable changes, not just in their clinical presentation or their function, which can result from frailty, but underlying biological markers. I'd like to show you what that might look like in the face of a stressor conceptually. Next slide, please. Here you see a lovely figure created by Ravi Vardhan and Chenli Zhu, looking at stress response dynamics for people who are frail in the top left, to pre-frail in the middle, to frail on the right. And let's just imagine that a robust person on the top left has a stressor like gets the flu. And the depth of the bowl that that person is sitting in is a marker of the resilience and robustness of their ability to bounce back from the flu, to recover. As they become more frail, the bowl gets wider and wider, and the ability to bounce back gets shallower. And we certainly see that as people become more and more frail in terms of both length and time to recovery from a stressor and diminished likelihood of recovery. Next slide. So to conclude, we have evidence for a frailty clinical syndrome with a clinical presentation, which marks a distinct physiologic and biologic status, with compromised ability to maintain stable homeostasis and handle stressors, and identifies a group at high risk. The syndrome is chronic and progressive and has a latent phase before the clinical presentation emerges. And the homeostatic compromise that is evident in the individual is marked when the system gets stressed. And it appears that underlying all of this are alterations in energetics in our bodies, which fuel the maintenance of the complex dynamical system of resilience. Next slide. How does this then get used clinically? Well, what are the clinical implications? Next slide. Well, certainly applications in terms of screening, tracking, diagnosis, prognosis, palliation, decisions about palliative care, prevention, treatment, and the health system. Next slide. The identification of the frailty syndrome and physiologic precursors would enable identifying treatments and prevention appropriate to the stage of energetic function, and likely will need to affect the multiple pathways of this multi-system dysregulation that underpins the clinical presentation. This will require effective screening and targeting, and thinking about how we even redesign our health systems to compensate for vulnerabilities of older adults who are frail, as well as when to implement palliative care when, for example, people with 5 clinical criteria for frailty are at very high risk of mortality and very low risk of being able to recover. To end, as we think of, next slide, please, as we think about treatment and prevention, it's important to note optimistically that in people with less than 4 and 5 criteria, with 1 and 2, actually, there's evidence of the potential to prevent incident frailty through both physical activity and the Mediterranean diet, and potentially higher protein diets. And also that people who are phenotypically frail, at least before they have 5 frailty criteria, are able to respond to interventions. Next slide, please. The evidence on physical activity is particularly intriguing to me because we know that in the Frailty Syndrome at the top in the clinical presentation, that declines in physical activity are a hallmark, but declines in physical activity are also causal of dysregulation of almost everything, every dysregulated system, both physiologic and cellular and molecular, that's associated with frailty. And this suggests that as we look at treatments or for other kinds of prevention for frailty, next slide, we similarly want to look for things, for interventions that would, go back one, please, would actually affect, go ahead one, would actually affect many systems simultaneously and not just one in a clinical condition. So I'll end here with the last slide to say that understanding the basis for frailty can lay the basis for prevention and treatment, but it can also lay the basis, I believe, for understanding what resilience really is and how it unravels. Thank you very much.
That was a very, very elegant overview and summary of a lot of data condensed in very short time. So thank you so much. You have a lot of questions, and in the interest of time, I'm going to pick some and probably paraphrase. But one of the questions is about, given that you said that kind of later stages of frailty, particularly score of 5 is sort of the point of no return, do you think that the population we should target for interventions is the pre-frail population?
So I think that's a critically important question. And the evidence is that the malleability certainly is in the pre-frail population of 1 or 2 criteria, maybe in those with 3 criteria, and then diminishes thereafter. And so if we want to prevent frailty and target people at higher risk of frailty, it would certainly be in the 1 or 2 criteria. If we want to prevent progression, we want to look at people with 3.
Okay. And then there were a couple of questions about the impact of certain conditions or disease, more conditions like oral health and sarcopenic obesity and how those interplay with frailty.
Sure. I say sure, but I think we still need a lot more knowledge on these. But certainly oral health is very important because people who are edentulous or have periodontal disease are at high risk of undernutrition and potentially particularly decreased protein intake. And I think the evidence supports the observation that protein intake is really critical to the maintenance of muscle mass and the prevention of frailty. So oral health, I think, very much matters here, and probably for many other reasons as well. On the sarcopenic obesity side, I think that there's certainly studies, a range of studies showing that you can be both frail and obese. I think the challenge, which Sara and I were talking about before, is that if losing weight is indicated, how to approach that so that people do not also lose muscle mass.
Correct, yes. And then I think the last question, oh gosh, okay, is what is your thought about screening earlier, like in midlife for frailty?
Mm-hmm. So I think that it probably depends on the population. For example, we know that the rates of frailty are elevated in middle-aged people with HIV/AIDS. Now we're seeing much less AIDS, of course, in the face of antiretroviral therapy, but in that group, the presence of frailty actually alters the response to antiretroviral therapy. So understanding targeting to that group would really matter. Similarly, what we're seeing is that with increasing length of life, so we've added 30 years to human life expectancy in the West, and the rest of the world is catching up fast. But what's not catching up is health span. And in fact, what we're seeing is people living 30 years longer with much more chronic disease for many more years. And I believe that the evidence suggests that there's both a primary frailty associated with aging and a secondary frailty with the same phenotype and probably the same final common pathways biologically and physiologically, but that this secondary frailty could well be kicked off by catabolic chronic diseases, inflammatory diseases. And so in people with such diseases, whether it's HIV or congestive heart failure, et cetera, targeting screening might really matter in middle age.
Okay, great, wonderful. Okay, well, again, thank you so much for very, very informative and exciting talk. I wanted to just mention a few other housekeeping items for the group to remind them of the International Conference on Frailty and Sarcopenia Research in March of 2023 in Toulouse, France. So please attend. And also the next session of our Frailty Seminar Series in January on the 11th will be a panel discussion by Dr. Luigi Ferrucci, Susan Howlett-Dalhousie, and Christian Leuenberg about mechanisms of frailty. And again, I want to thank you, Dr. Fried, for joining us for this presentation.
My pleasure. It's good to be with all of you. Thank you.